These are fossilized eggs of dinosaurs. But did you notice the environment around these eggs? Because shockingly, these fossilized eggs are not of the dinosaurs of Earth, but of these scary dinosaur-like creatures that ruled millions of years ago on Mars, which is 400 million kilometers away from Earth, whose pictures have been captured recently by NASA's Curiosity rover. Scientists around the world are surprised to see them, and many news articles have also been published on this shocking news. And not only this, recently NASA's Perseverance rover captured another scary image in which structures like spider eggs were seen on the surface of Mars. But when NASA's Curiosity rover saw these round, shiny, clustered joint eggs in this barren world covered with red dust, this news went viral all over the internet. It was said that maybe NASA is present on Mars more than us. Something is being hidden about ancient life. Even some such theories are going viral on the internet, according to which these eggs of ancient organisms found on Mars are not just fossils, but proof that once upon a time, giant creatures and intelligent predators lived on Mars. The same predators who built rockets and fled from there after Mars was destroyed and settled on Earth, and perhaps we humans are their descendants. So what is the truth? Are these ancient fossilized eggs seen by NASA's Curiosity and Perseverance rover really of organisms that lived on Mars billions of years ago? Did creatures like dinosaurs really live on Mars? And what is the connection of humans with the past of Mars? Let's find out in today's new episode. So hello guys, I'm Kaushik, and let's start another new episode. Friends, before moving on to the video, just like you are connected with me on YouTube, imagine a planet whose soil is red and strange and scary creatures are swimming in its vast ocean. But as soon as you are watching them from your spaceship, your eyes go to the sky because there too many terrifying creatures are flying with their wings spread. This is Mars 3 billion years ago. But among these joint creatures living on Mars, another species ruled. They did not hunt alone, but in groups. They kept chasing their prey until it fell down from exhaustion and then suddenly attacked from all sides with their advanced weapons like guns and bows and arrows. The most frightening thing was that these creatures were not only powerful, but also very intelligent. They knew mathematics, they could make rockets, and they already knew that Mars was slowly dying, which was absolutely true because now the magnetic field of Mars is slowly weakening, due to which its atmosphere was being lost to space. With a thin atmosphere and no magnetic field, the sun's deadly radiation started reaching the surface of Mars. The oceans were drying up and the Earth was turning into a barren desert. Then these intelligent predators of Mars made their biggest plan to go to Earth, and perhaps this is the reason why we are here today. But the question arises that how do we know all this? So the reason for this is these two mysterious pictures. Now, for example, if we talk about this picture, it was taken on August 15th, 2025 by NASA's Curiosity rover in Mars Geddes Valley's ridge. The strange shapes present in it looked exactly like fossilized dinosaur eggs, round, clustered, and with a smooth surface. And after going viral on the internet, many people believe that these are fossilized eggs of giant creatures like dinosaurs that ruled Mars billions of years ago. Apart from this, look at this second picture, which was captured a few months ago by NASA's second rover, Perseverance. In this, thousands of ant-like small round structures were seen in clustered form. This also went viral on the internet at that time, and it was described as fossilized eggs of creatures like ancient spiders of Mars. But are both these pictures really fossilized eggs of creatures of Mars? Well, maybe yes. And there are many reasons for this, due to which people from time to time associate the past of Mars with an advanced civilization and life. For example, look at this Ganesha statue on which we made a video some time back. And not only this, statues like Buddha and even perfectly shaped doors have been seen on the surface of Mars, exactly like we make them on Earth. All this points towards a big story, a story which tells that perhaps our history is not like what we have been taught in school books. These mysterious pictures of Mars increase both fear and curiosity about Mars in humans. Fear is because if all these pictures are real, then it means that perhaps this theory is also correct, that the descendants of us humans came to Earth from Mars. Maybe Mars was our real home before Earth. Many other creatures also live there with us, just like they live on Earth today. But when Mars' magnetic field weakened and it was on the verge of being destroyed by cosmic radiation, our ancestors decided to find a new home in the solar system, could survive. And the most obvious choice for them was their neighboring planet Earth. Yes, the same Earth which is our home. Centuries ago, we saw the hazy surface of Mars through a telescope and thought that there would be water and maybe some life living there. But now we have not only eyes, but rovers that reveal the truth of this planet's soil and rocks by touching them, smelling them, and lighting them with lasers. That is why on August 15th, 2025, when NASA's Curiosity rover, while climbing Mount Shark, saw these fossilized dinosaur egg-like formations in the Boxworks, a part of the Getty's Valley's Ridge, the first task was to test them. For this SUV-sized rover has many scientific payloads installed. So the first thing that works is the mast cam. This is a high-resolution color camera mounted on Rover's head. When it captured these joint egg-like structures in close-up images, it was clearly visible that their color was different from the rest of the rocks. In the pictures, many bright white and light gray were visible, which were very similar to the fossilized eggs of creatures seen on Earth in clustering. After this comes the turn of ChemCam, i.e. Rohr's laser gun. Imagine a small bright light suddenly falls on the rock and the rock vaporizes with a spark. This is laser-induced breakdown spectroscopy, through which Rohr can study the atomic structure of any object. And when this laser was put on these egg-shaped formations, the chemistry revealed that they are made of unusually high concentration of calcium and sulfur. And this is a shocking fact, because till now, the outermost shell of all the eggs of organisms seen on Earth is also made of calcium. Apart from this, other instruments of curiosity gave a hint in the research that these could really be the eggs of some creature present on Mars. But despite all this, NASA says that these formations are just rocks made of erosion in the presence of water on Mars billions of years ago. But a large number of people on the internet are not ready to believe these things of NASA. According to them, NASA is hiding the truth of life on Mars by lying. And this is not the first time that NASA has been accused of hiding evidence of life on Mars. In 1976, Viking landers had confirmed in a soil experiment conducted on Mars that when water is poured into the soil, gases like carbon dioxide and oxygen come out of it, which was a proof of microbial life. But later, NASA said that it was just a chemical reaction. This case is controversial even today because how did NASA back out from its statement so soon after accepting signs of life in the first experiment? Apart from this, LH-8401 meteorite was found in Antarctica in 1984 and fell to Earth from Mars. Microscopic carbonates, globules, and structures were found inside it, which looked exactly like bacteria and fossils. In 1996, NASA told the whole world that perhaps this is evidence of Martian life. But since then, NASA has not made any official statement on this. In 2012, Curiosity Rohr detected organic molecules and methane spikes in the mudstones of Gale Crater. The conditions are related to organic life on Earth. But here too, NASA did not make any major official statement on this. And now in the year 2025, the same pattern is being repeated in the case of egg-shaped formations. Even after several decades of research, there are many such mysteries about Mars which still raise questions on the understanding of scientists. We tried not to link these unclean pictures to conspiracy theories about aliens and tried to fit them into today's science. But when such strange things are repeated again and again, and each time they are dismissed as erosion, then it is natural to raise the question whether conspiracy theories give the real logical answer. For example, look at this scary picture captured by NASA rovers on Mars. Many people made theories that it was made by ancient aliens on Mars because it was cut so accurately in the rocks. But some scientists came and said without proof that it was made of erosion. After this, look at this picture in which a statue resembling Lord Ganesha was captured by the rover on Mars. It was clearly visible that it was crafted very precisely. Many people considered it a real crafted statue and proof of intelligent beings living on Mars in the past. But here, also a group came, and without any proof, they called it erosion. However, later its truth also came out, and finally, when recently Curiosity Roar took pictures of shapes like fossilized eggs, here also some scientists again said that this is the result of erosion, meaning it is such that no matter how many proofs are given to you, the answer will not change. Now, here I am not saying that there is or was life on Mars, but when you repeatedly believe that at one time there were oceans like Earth on Mars, then why can't these mysterious pictures also be the marks of some life on Mars at that time? Calling everything erosion every time raises the question many times that NASA and the world's space agencies are not hiding any big secret from us. And if these pictures turn out to be true, and they are indeed fossilized eggs of joint creatures that lived in Mars's past, then how deeply will this affect humans' understanding of Mars and our history? So, Gaddy's Valley Ridge is a place on Mars that scientists believe represents the most turbulent period in the planet's history. Sometimes massive floods occurred here, and sometimes huge landslides swept everything away and deposited it in a ridge. This is why this area is considered the most mysterious archive of Mars's past. NASA's rovers detected pure sulfur crystals on these ridges. This was extremely unusual because sulfur crystals are formed only after rare and complex chemical reactions. This meant that hydrothermal processes were going on even below the surface of Mars. Just like deep sea winds on Earth, these processes could have energized microbial ecosystems. This makes it a strong possibility that life may have existed on Mars at some point. But only photographs or surface tests are not enough to know the truth of these egg-like formations. The real truth will come out only when we bring back soil and rock samples from Mars. This is the reason why NASA has recently announced that it will launch a Mars sample return mission around 2030. Similarly, the European Space Agency's ExoMars mission is also ready, in which a special rover will be capable of drilling about 2 meters below the surface of Mars. Scientists believe that if there has ever been life on Mars, then its best chances are that it is still preserved in the deep subsurface layers where radiation cannot reach. The drill of ExoMars will reach exactly those untouched layers. That is, now these missions are our biggest hopes. Those missions that can bring out the real truth of these mysterious stories of Mars. But the real question still remains that if these missions prove that complex life existed on Mars in the past, and these images are indeed fossilized eggs of some joint Martian creatures, then this discovery will change the entire understanding of humans overnight. Our theory of evolution will be shaken, and the possibility will become very strong that theories that say that humans did not originate on Earth but migrated from Mars can be proved true. On the other hand, even if it is just natural geology, this discovery will be equally big because it will mean that water existed on Mars for a very long time, and where there is water, there is always a possibility of life. That is, even in this condition, even if these are not the eggs of any Martian creature, it would still be a strong indication that when Mars was habitable, there must have been life there, and its traces would still be buried somewhere on the surface or in the depths of this planet. Now, the last question is to you. Is NASA really hiding the truth of life on Mars from us? And are these pictures taken by Curiosity Roar really fossilized eggs of some joint dinosaur-like creature present in Mars' past, or is it just a natural formation? Do tell me your answer by writing in the comments section. If you like the video, then along with liking this video, do share it with your friends. If you have not yet followed me on Instagram, then go and follow me on Instagram. The link is in the description box. If you are new to the channel, then along with subscribing to the channel, turn on the notification bell. If you like this video, I would recommend you to go and watch the next video in which we have talked about what China's Zhurong rover saw on Mars. You must know that recently China also sent its Zhurong rover to Mars, and it made many big discoveries, such discoveries about which NASA never tells you. But what were those discoveries? To know, watch this video. You open your eyes to the night sky, and there it is, glowing faintly like a restless ember in the dark. Mars. For thousands of years, humanity has looked up at that rusty dot with a strange sense of wonder, curiosity, and even fear. Unlike the glittering stars or the gentle shine of Venus, Mars is different. It feels alive, as if it hides a secret it refuses to tell. And perhaps deep down, you've always asked the same question that astronomers, poets, and dreamers have whispered across centuries. Did life once exist there? The thought is unsettling, isn't it? Because if Mars once carried life, then Earth is not unique. The miracle you and I call life might not be a miracle at all. It might be a pattern, a cosmic inevitability. That changes everything, not just about how we see the universe, but how we see ourselves. The red planet has haunted civilizations since the dawn of recorded history. The Babylonians named it after their god of war. The Greeks called it Ares. The Romans gave it the name we still use today, Mars, the bringer of conflict, blood, and passion. Even in astrology, Mars has always been the planet of action and energy. But beyond myths and symbols, something deeper pulled at our ancestors' hearts. They noticed the way Mars moved, how its path across the sky seemed erratic and unpredictable. Unlike the fixed stars, this world wandered. It was alive in its own way. And with each passing century, with every new telescope pointed toward that glowing red disk, the mystery only grew. When early astronomers peered through their primitive lenses, they swore they saw canals carved into the Martian surface. Great rivers of water, they thought. Civilizations, perhaps, irrigating their fields under an alien sun. It was a dream, but a dream powerful enough to inspire novels, operas, and fears of invasion. But let's pause. Let's breathe. And let's ask ourselves, why does this planet stir such emotion? Why do you and I feel that Mars is more than rock and dust? Maybe because it feels familiar. Maybe because it feels like home. You see, Mars isn't some distant gas giant wrapped in storms of hydrogen and helium. It isn't frozen like Pluto, nor burning like Mercury. Mars is Earth's near twin. Smaller, yes. Colder, yes. But when you look at its valleys, its mountains, its deserts, you recognize them. It mirrors landscapes you've seen on your own planet. The canyon called Valles Marineris stretches 10 times longer than the Grand Canyon. Olympus Mons, its great volcano, rises taller than 3 Mount Everests stacked together. And the polar caps, yes, actual ice, glitter like frozen crowns at its poles. And so the question grows sharper. If Earth blossomed with oceans and forests and creatures, why not Mars? Could rivers have once flowed there? Could microbes have crawled, swum, or thrived beneath its soil? Could something greater have stirred in its ancient air? The more scientists studied, the more clues they uncovered. Meteorites from Mars landed on Earth, blasted off its surface by ancient impacts, carrying secrets locked in their minerals. Telescopes scanned its atmosphere, detecting strange gases that rose and fell like whispers. And, rovers, tiny robotic explorers, crawled across its crimson plains, sending back photographs that shocked the world. Dry riverbeds, pebbles shaped by flowing streams, minerals that could only form in liquid water. Each discovery was like a breadcrumb, leading us deeper into the labyrinth of Mars's past. But here's where the twist arrives, and I need you to feel it in your bones. Mars may not just be a planet we study, it may be a planet that once lived. And if it lived, then what happened to it? What force stripped its seas, choked its skies, and left it barren? Did life thrive there only to be extinguished? Or is something still hiding, buried deep beneath its frozen crust, waiting to be found? Imagine the chill that would crawl up your spine if tomorrow NASA stood at a podium and announced, "Yes, we found proof Mars once had life." The ripple effect would shake every school, every religion, every philosophy. You would never look at the night sky the same way again. And so, as we step into this mystery together, let us walk carefully, because Mars is not just a world of dust. It is a mirror of Earth's past, and perhaps a warning of Earth's future. The story of Mars is not about science alone. It is about identity. It is about the loneliness of the cosmos, the hunger for connection, and the eternal question, are we alone or have we always been part of something larger? This, then, is our journey. From ancient myths to cutting-edge rovers, from fossilized riverbeds to frozen polar caps, from dreams of canals to whispers of microbial life. Together, we will trace the saga of a world that sits 225 million kilometers away, yet feels close enough to touch. So, take a breath. Let the story unfold. Because Mars is calling you, not with silence, but with a question that refuses to die. And as we move forward, let's step deeper into its timeline. Let's peel back the layers of dust and rock and see how Mars transformed from a warm, watery world into the cold desert we see today. Close your eyes and imagine Mars, not as the barren wasteland you know today, but as a world alive with oceans, lakes, and rivers. Imagine waves crashing against ancient Martian shores. Imagine rain falling from alien clouds, carving streams through valleys of red stone. Hard to believe, isn't it? Yet, all evidence points to a shocking truth. Mars was once blue. Billions of years ago, long before life crawled onto Earth's land, Mars was different. Its skies may have been thicker, holding in warmth. Its magnetic field, still alive, may have shielded it from deadly solar winds. And most importantly, its surface carried water, flowing freely, shaping mountains and filling craters. Water is not just a liquid, it is life's invitation. Wherever Earth's oceans reached, life blossomed. From microbes clinging to volcanic vents to coral reefs teeming with color, water has always been the stage for creation. So when rovers like Opportunity and Curiosity sent back images of Martian rocks shaped by streams, the world gasped. When scientists found tiny mineral deposits that form only in the presence of water, the silence of space seemed to echo with possibility. Think of Gale Crater, where Curiosity roams. Billions of years ago, it was not a crater of dust, it was a lake. Its sediments tell the story, layers upon layers built by ancient water, preserved like pages in a planetary diary. Each layer whispers, I once held rivers, I once held lakes, I once held potential. And then there are the valleys, immense scars on Mars's surface. Valles Marineris, the canyon so vast it dwarfs Earth's Grand Canyon, may have once carried floods of unimaginable scale. Channels branch out like veins across the planet, etched by water that must have rushed with force. And near the poles, frozen beneath the surface, radar hints at subglacial lakes, still liquid, still waiting, still alive with mystery. Now pause with me for a moment. Picture yourself standing on Mars, not today, but in that ancient era. The horizon is still tinted red, yes, but above you the sky may hold a soft blue glow. Clouds drift. A breeze ripples across a shallow lake at your feet. Could you hear waves? Could you smell rain? For just a moment, Mars feels like a twin of Earth. Not a stranger, not a desert, but a sibling world where life could have taken its first breath. This is not science fiction, it is science memory. Mars carries the scars, the evidence, the fingerprints of water. And wherever water flows, life at least has a chance. But then comes the heartbreak. Something changed. Slowly, quietly, Mars lost its warmth. Its magnetic shield faded. Without protection, the sun's fierce winds stripped away its atmosphere, molecule by molecule. The air thinned, the pressure dropped, the lakes shrank, and the rivers froze. Imagine watching oceans evaporate into the void of space. Imagine entire ecosystems, if they existed, gasping their last beneath a dying sky. Mars transformed from blue to red, from wet to dry, from alive with possibility to barren silence. And here's where the story twists again. If Mars truly once had water, and if water means life, then we are forced to ask, did something live there? Even if only microbes, even if only simple cells, did Mars once breathe? And if so, did anything survive beneath the surface, clinging to warmth near volcanic vents, or hidden in salty underground lakes? You feel the weight of that question, don't you? Because if life began on Mars, then maybe life is not a miracle reserved for Earth. It is a rule, a cosmic rhythm. And if it ended there, then maybe the same fate could one day touch us. Mars is not just a dead planet, it is a cautionary tale. A world that once had oceans, yet lost them. A world that may have once had life, yet watched it vanish. And as you stand here on Earth, under blue skies and beside flowing rivers, you cannot help but wonder, how fragile is our own paradise? The story of ancient Mars is not over. Each rover that digs, each satellite that scans, adds another clue. And with every discovery, one truth grows stronger. Mars was not always the way it is today. Something dramatic, something catastrophic, reshaped it. So as we leave behind the memory of a blue Mars, let us walk into the mystery of its death. Because to understand whether life existed there, we must first understand how life might have ended. Close your eyes for a moment and picture this: a planet with rivers, oceans, and perhaps even rain. Now imagine the slowest kind of death, not a sudden explosion, not a violent impact, but a gradual fading away. That's what happened to Mars. It wasn't destroyed in a single moment. It was stripped piece by piece of its very soul. Billions of years ago, Mars had something vital, a magnetic field. Just like Earth, it wrapped the planet in an invisible shield, protecting it from the sun's deadly solar winds. Without this protection, the atmosphere of any world is vulnerable, like a candle flame in a storm. But Mars was smaller than Earth. Its heart cooled faster, its core solidified, and with that change, its magnetic field faded. The shield was gone. And the sun? The sun showed no mercy. Solar winds began tearing at Mars's atmosphere, atom by atom, molecule by molecule. Over millions of years, the once thick sky of Mars was shredded and lost to space. Picture standing there watching your blue skies fade to thin, weak air. The oceans begin to boil away, not from heat, but from lack of pressure. Rivers shrink. It's not a dramatic event, it's worse than that. It's a quiet suffocation, the kind of slow death where no one hears you scream. NASA's MAVEN spacecraft, launched in 2013, revealed this chilling truth. It measured how solar radiation continues to peel Mars' atmosphere even today. Even now, the winds of our star still steal what little air Mars has left. Imagine knowing your planet is bleeding into space, and there's nothing you can do to stop it. And here's the twist. This wasn't just the death of an atmosphere. It was the death of potential. Without air, there could be no stable liquid water. Without water, life, if it had ever taken root, was cornered, starved, pushed underground. Mars didn't just lose its skies, it lost its future. But pause with me. Let's make this personal. Because when you look at Earth with its thick oxygen-rich atmosphere, its protective shield, its balance of pressure and warmth, you realize how fragile it all is. If Mars could lose its sky, what makes us so safe? Earth's magnetic field still hums, still guards us, but even it is shifting, weakening in places, drifting over time. Could what happened to Mars one day happen here? This is why Mars is not just a story about another planet. It is a warning, a mirror held up to Earth, showing us what can happen when nature's delicate balance is broken. A planet that once may have looked like ours is now a barren graveyard. And you can't help but shiver at the thought, is this our distant future? Still, the most haunting part is this: the stripping of Mars's Atmosphere might not have been the end of life there. It may have been the beginning of its exile. Think about it. If life had already emerged, microbes could have adapted, digging down into the soil, retreating into underground aquifers, hiding in salty brines where liquid water could survive despite the cold. They may still be there now, silent, waiting. You see, the story of Mars losing its atmosphere is not just a tale of death. It is a tale of survival. For while the surface froze, the underground may have become a sanctuary, a last refuge for life, clinging to the faint warmth of volcanic activity or the chemistry of saltwater pockets. And so every time a rover drills into Martian rock, every time radar scans beneath its icy poles, scientists hold their breath. Because they're not just looking for rocks, they're looking for whispers, fossils of microbes, chemical traces of metabolism, the smallest clue that says, we were here, we fought, we survived. But here's the twist that keeps scientists awake at night. If life never existed on Mars, then why not? With water, with an atmosphere, with billions of years of opportunity, why would it fail? That answer might be more frightening than finding life, because it could mean that life itself is rare, fragile, and Earth's existence is an impossible accident. So either way, whether Mars once lived or whether it remained barren, the truth shakes us. We either discover that life is everywhere, or we discover that life is almost nowhere. Mars lost its sky, but it didn't lose its ability to make us question everything. And as we step deeper into this mystery, we now turn to the detectives of this story, the explorers we have sent to walk its dusty plains, to dig its ancient soils, to stare into the face of a dead planet and ask, what secrets are you hiding? The rovers, the silent heroes of Mars's saga. And they are the ones who have shown us the closest glimpses of its truth. Imagine this. You are standing on the launch pad, staring at a rocket pointed toward the heavens. Inside its nose cone is not a human astronaut, but something humbler, something smaller. A machine with wheels, cameras, and a heart that beats in circuits and solar panels. A rover, a robot explorer that will go where you cannot, walk where you can only dream, and touch the surface of another world on your behalf. When those rockets lifted off, they carried more than metal and wires. They carried humanity's longing, our need to know if Mars still whispers with the memory of life. The first successful visitor to Mars was not even a rover, but NASA's Viking landers in the 1970s. They dug, they tested, and they searched for signs of life in the soil. And while the results were confusing, some tests hinted at chemical reactions that might resemble metabolism, others showed no organics at all. The Vikings did something even greater. They proved that we could touch Mars. They planted our flag of curiosity in its soil, but it was the rovers that truly stole our hearts. Sojourner in 1997 became the first to roll across Mars' dusty plains. Small, clunky by today's standards, but historic. Its tracks were like the first footprints on a new beach, proof that we could not only reach Mars, but move on it, explore it like a wandering geologist. Then came the twins, Spirit and Opportunity. Launched in 2003, they were expected to last 90 days. Spirit lasted over 6 years. Opportunity, 15 years. Think about that. 15 years of loyal service, braving dust storms, freezing nights, and endless isolation, like just to keep sending back whispers from another world. When NASA finally lost contact with Opportunity in 2019, after a massive storm cloaked it in darkness, scientists around the globe wept. They sent one last call, "My battery is low and it's getting dark." A message that broke hearts because it sounded less like a machine and more like a friend saying goodbye. But what did they find? They found proof, not of life itself, but of what life needs: water. Spirit discovered rocks altered by ancient hot springs. Opportunity rolled across plains filled with tiny spherical blueberries, mineral deposits that only form in water. Together, they showed us that Mars was once wet, and where water flowed, life might have had a chance. And then came the giant, curiosity. In 2012, it landed inside Gale Crater using a sky crane that lowered it gently to the surface in one of the most daring space maneuvers ever attempted. Its mission? To search for the chemistry of habitability. And it delivered. Curiosity drilled into rocks, tasted their minerals, and found organic molecules, carbon compounds that are the building blocks of life. Not proof of organisms, but evidence that Mars' environment once held the right recipe. Imagine that moment. Imagine a rover millions of kilometers away, drilling into a stone older than any human civilization and revealing chemistry that whispers, I could have supported life. And still, the story didn't end. Perseverance, landing in 2021, carried something no other rover had before: the ability to collect and store samples for a future return to Earth. Think about that. Uh, for the first time in history, rocks currently sitting in Mars's Jezero crater are waiting to be picked up and flown back across space. When those samples arrive here in our laboratories, humanity may finally answer the question once and for all: did life ever exist on Mars? But Perseverance is not just a scientist, it is a storyteller. With its microphones, it recorded the first sounds of Mars: the whisper of wind across alien dust, the crunch of its wheels rolling over stones. For the first time, you didn't just see Mars, you could hear it. And suddenly, it felt less like a distant world and more like a place you could walk upon yourself. And who could forget Ingenuity, the tiny helicopter that rode along with Perseverance? Meant only as a short experiment, it became the first aircraft to fly on another planet. A fragile drone buzzing through thin Martian skies, proving that flight was possible where the air is barely 1% as dense as Earth's. With every flight, Ingenuity shattered expectations, flying dozens of times longer than planned. Like Opportunity, it became more than a machine. It became a symbol, proof that even fragile dreams can soar. Each rover has been a chapter in the same story, a story of persistence, of survival, of humanity reaching into the darkness to find light. They are our eyes, our hands, our silent companions in the void. And through them, Mars has gone from a blurry dot in the sky to a living landscape in our imaginations. Yet for all their discoveries, the riddle remains unsolved. They have shown us rivers, lakes, organics, and even the chemistry of habitability, but not life itself. Not yet. And so the anticipation grows, because if the rovers cannot prove it, maybe the samples they've collected will. And if those samples reveal even the faintest trace of life, fossilized cells, microbial residues, or chemical patterns that only biology can explain, the world will never be the same. As you think about these silent explorers rolling under alien suns, you realize something profound. We didn't just send robots, we sent hope, we sent pieces of ourselves. And in their discoveries, we see not just the story of Mars, but the story of us. Now, let us take a step deeper. We've seen the rivers, the rocks, the rovers. But what about the strange signals, the mysterious gases, the hints of something still stirring today? Because while the past of Mars is fascinating, its present might be even more shocking. And that brings us to the mystery of methane. Picture this: a silent rover sits alone in Gale Crater. Its cameras sweep across the horizon, showing nothing but dust, rocks, and distant hills. The scene feels dead, lifeless, still. But then, beneath the thin whisper of air, something invisible stirs. Something you can't see, but something that carries the weight of one of the greatest mysteries in science: methane. On Earth, methane is familiar. You find it in natural gas, you smell it in swamps, you even see it bubbling from the stomachs of cows. But here's the secret. On Earth, most methane comes from life. Microbes breathe it out. Organisms create it as part of their metabolism. So when scientists detected methane in the thin Martian air, it was like a shockwave through the community, because methane should not survive long on Mars. The sun's radiation and chemical reactions destroy it quickly, which means if it's there, something must be replenishing it. And that is where the riddle begins. Back in 2003, telescopes on Earth hinted at plumes of methane on Mars. In 2014, NASA's Curiosity rover confirmed it, detecting spikes of methane levels that rose and fell like mysterious breaths. Imagine that. A machine sitting on alien soil, sniffing the air and finding chemicals that whispered, "Something is happening here." But what? There are two possibilities. One is geological. Deep beneath Mars, water might react with rocks, creating methane in a process called serpentinization. Non-biological, purely chemical. A cold explanation, but still fascinating. The second possibility is the one that sends chills through your spine. Life. Microbes buried underground, shielded from radiation, may still be breathing out methane as they cling to existence in hidden aquifers or salty brines. Alive, not fossils, not memories, but alive, right now. And here's the part that deepens the mystery. Curiosity saw methane rise in the Martian summer, then fade in the winter. A cycle, a rhythm, just like the breathing of something alive. But science is never simple. The European Space Agency's Trace Gas Orbiter looked down from orbit and found nothing. No methane, no plumes, no spikes. How could this be? Was Curiosity mistaken? Was the methane trapped close to the surface, vanishing before reaching space? Or is Mars playing tricks on us, releasing its secrets only in whispers, never in shouts? Think about the tension this creates. On one hand, you have a rover on the ground saying, "It's here, I can measure it." On the other, a spacecraft in orbit saying, "No, it's not, I see nothing." It's like listening to two witnesses give opposite testimonies in the same courtroom. The truth is there, but hidden. And this is what makes methane so haunting. If confirmed, it could mean that Mars is not just a graveyard of the past, but a living world, a world where microbes might still stir just beyond our reach. Now imagine the day when a drill goes deeper, when a sample from underground is lifted up and analyzed. Imagine the moment when instruments detect not just methane, but complex patterns, signatures that cannot be explained by rocks alone. The silence of space would break, because that discovery would not just be about Mars, it would be about life beyond Earth. And let's pause here. Let's really feel the gravity of that. You have lived your entire life in a universe where Earth is the only known cradle of life. Every story, every belief, every dream has been shaped by the assumption that we are alone. But if Mars has life, even the smallest, simplest cells, that assumption dies. And with it, the way you see the universe changes forever. Because then, life is not rare, life is not a miracle, life is a rule. A natural outcome of chemistry, waiting to bloom wherever water, energy, and time exist. And if it happened on Mars just next door, then it must be everywhere. On icy moons, in distant exoplanets, in galaxies far beyond our own. Suddenly, the cosmos feels less empty. Suddenly, the night sky feels full of neighbors. But here's the haunting twist. If life did exist and still exists, why is it only microbial? Why did it never grow, never flourish into forests, animals, civilizations? Was Mars too unstable? Was it doomed from the start? Or is life's journey fragile, a narrow path where most worlds stumble and fall, never reaching beyond the microscopic stage? The methane mystery does not just raise the possibility of life, it raises questions about why life thrives here and not there. And that is why every spike of methane, every disputed detection, every whisper of organic chemistry keeps scientists awake at night. Because in those molecules may lie the first undeniable proof that Earth is not alone. So, as we leave behind this riddle of invisible gas, let us look at the physical clues carved into the very surface of Mars. The landscapes that scream of rivers long vanished, the canyons that tell of water's touch, the rocks that preserve a billion-year memory. Because methane is the invisible mystery, but the land itself is the diary. And that diary may hold the pages that reveal what Mars once truly was. That it stretches beyond the horizon. The air is thin, the sky tinted in pale orange, and before you lies a scar carved into the planet's skin, Valles Marineris. This canyon is not just big, it is the largest in the solar system. 4,000 kilometers long, 10 times longer than the Grand Canyon on Earth, and 7 kilometers deep. It is a wound, a story, a fossil. Because this canyon, like so many features on Mars, whispers of water. Not the still, frozen water we see trapped in its poles today, but rushing torrents that once carved their way through valleys and craters. The Martian surface is covered with these scars, dry riverbeds, deltas, gullies, and channels that could only have been made by water flowing over long stretches of time. Take Jezero Crater, for example, the landing site of the Perseverance rover. From orbit, it looks ordinary, another round basin among countless craters. But when you look closer, you see something astonishing: the unmistakable shape of a delta. Just like the Nile fans out into the Mediterranean, Jezero once held a river flowing into a lake. Sediment piled up in branching fingers, like freezing in stone the memory of water that once poured across this land. Scientists chose this site not by accident, but with purpose. If life ever thrived on Mars, deltas rich in nutrients, calm in waters, are the places where fossils might remain. And then there is Gale Crater, where curiosity roams. Its layers are like a history book, thin bands of clay, sulfates, and minerals that tell of lakes filling and drying over and over again. Imagine pages in a diary, written not in ink, but in stone. Each layer says, "I once held water, I once held hope." But perhaps the most striking feature is not a single canyon or crater, but the network of valleys that spread across the planet. From orbit, they look like veins, intricate, branching, winding across the surface. They are the fingerprints of rivers long vanished, carved in an age when Mars was warmer, wetter, and alive with storms. Think of it this way: if you were an astronaut walking on Mars today, your boots would crunch on dust and stone. But beneath your feet, frozen in silence, is the ghost of flowing streams. You could stand inside an ancient riverbed, stretch your arms out, and imagine the current once rushing past. You would be standing in the fossil of a river. And here's where the story turns haunting. These landscapes are not just evidence of water, they are evidence of time. The rivers did not last forever. They came, they shaped, they vanished. Like a song cut short, Mars's watery era ended. The valleys dried, the lakes froze, the oceans, if they ever existed, evaporated into the void. Mars became the desert we see today. But the rocks keep the memory. They are stubborn, refusing to forget. Curiosity, opportunity, and perseverance have all found minerals that form only in water. Hematite, clays, sulfates. These are not accidents. They are signatures, proof that Mars once had the chemistry of habitability. Now pause. Think about Earth's riverbeds. Think about the fossils found in ancient deltas here. Trilobites, shells, imprints of plants. On Earth, where water flowed, life always followed. Always. So when you see a Martian delta, when you trace with your eyes the dried banks of a Martian river, you cannot help but ask, did life follow here too? And if it did, then the stones you are looking at may hold not just the memory of water, but the memory of life itself. Tiny fossils invisible to the naked eye trapped in clay, or chemical traces like fingerprints left behind by something that once swam or crawled in Martian lakes. This is why scientists obsess over these fossil rivers, because they are more than geography. They are graves, or perhaps cradles. They are places where answers hide, waiting for the right tools, the right drills, the right eyes to uncover them. But here's the chilling part. These rivers tell us not just about the past of Mars, but about its fate. Because when you see a canyon as wide as Valles Marineris, when you see a crater that once held a lake, you realize something terrifying. Even worlds that bloom with water can die. Mars did. It lost its atmosphere, lost its warmth, and its rivers dried. And so, the fossil rivers of Mars are not just reminders of what was. They are warnings of what could be. As we step away from these valleys and canyons, let's follow the water deeper. Because while the surface dried, the question remains, could liquid water still exist today, hidden underground? Could lakes still survive, buried beneath the polar ice? And if so, could something be living there right now? Picture the Martian poles for a moment. From orbit, they shine like frozen jewels, vast caps of white and pale blue stretching across the rust-colored desert. At first glance, they look lifeless, like glaciers locked in eternal stillness. But beneath this ice, hidden away from the burning cold of the surface, scientists have found something astonishing: possible liquid water. It all began with radar. The European Space Agency's Mars Express orbiter, circling the planet since 2003, carries an instrument called MARSIS, a radar that can peer beneath the ground. For years, it scanned the polar regions, bouncing signals deep into the ice. And then, in 2018, the echoes revealed something remarkable. Under the southern ice cap, about 1.5 kilometers below the surface, the radar spotted a patch that reflected like no other. Smooth, shiny, bright. The signature was unmistakable: liquid water. Imagine what that means. While the surface of Mars is bitterly cold, far below freezing, with air so thin water would evaporate instantly, below the ice, conditions change. Salt in the soil lowers the freezing point. Pressure from the thick layers above traps warmth. Geothermal heat from deep inside the planet may still rise. Together, these forces can allow pockets of liquid water to survive even in such a hostile world. Close your eyes and imagine descending through that ice. You'd pass through layers of dust and frost, each one holding centuries of history. And then finally, you'd reach a dark underground lake, black, silent, and untouched for millions of years, a hidden ocean beneath a frozen desert. And here's where the story takes a thrilling turn. On Earth, wherever we find liquid water, we find life, even in the harshest places. Under Antarctic glaciers, in the crushing darkness of deep-sea vents, within salty underground lakes, life persists. Tiny microbes, extremophiles, thriving in conditions we once thought impossible. They don't need sunlight, they don't need warmth, they need only water, chemistry, and time. So when scientists say Mars may still hold liquid water today, what they are really saying is this: Mars may not be entirely dead. Somewhere beneath the ice, shielded from radiation, life could be clinging on, quietly, invisibly. Think about the implications. For decades, we looked at Mars as a barren world. But what if its life didn't vanish completely? What if it simply retreated underground, hiding in salty lakes or aquifers? That would mean life has survived two planetary worlds, Earth and Mars, side by side in the same solar system. The excitement doesn't stop at just one discovery. After the first radar results, follow-up studies suggested there may be not just one lake, but several, an entire network of underground reservoirs. Imagine a hidden plumbing system beneath the ice caps, stretching for kilometers. Of course, some scientists urge caution. Could the radar signals have been caused by unusual minerals instead of water? Could the bright reflections be illusions? The debate rages on. But even the skeptics admit the evidence is compelling. And here's the emotional truth: you don't need certainty to dream. You just need possibility. Because even the possibility of water today means Mars is not a planet frozen only in its past. It means Mars is still active, still mysterious, still holding secrets waiting for us to uncover. Now imagine the future. One day, perhaps, a lander or a drill will pierce through that ice. It will melt its way downward like a tiny submarine in slow motion. And when it finally reaches the liquid below, cameras and instruments will descend into the blackness. What will they see? Maybe nothing but salt and silence. Or maybe, just maybe, a faint ripple in the water, caused not by wind, but by something alive. Something that has been waiting in the dark for millions of years. If that moment ever comes, if we ever peer into that lake and see life swimming, the entire history of humanity will change in an instant. Because then we will know we are not alone, even in our own backyard. And here lies the haunting poetry of Mars. The surface screams death, dust, radiation, cold. But the ice whispers a different story, one of hidden survival, of life that adapts, of hope buried deep. So the question is no longer just, did Mars once hold life? The question becomes, could Mars still hold life right now? As we leave the frozen caps behind, our journey must now turn toward the mysteries in the air, the lost atmosphere of Mars. Because if Mars once had oceans and rivers, how did it lose them all? What force stripped it bare, turning it from blue to red? To answer that, we must look not at the surface, but the skies above. Look up at the Martian sky. It glows in shades of peach and gold, thin clouds drifting like wisps of smoke. But don't be fooled. This sky is a ghost. The air is so thin you could barely call it an atmosphere at all. Stand here without a suit, and your blood would boil before it froze. And yet, billions of years ago, this same world may have been wrapped in a thick, protective blanket of air, warm enough to hold oceans and storms. The great mystery is what happened to it. On Earth, our atmosphere shields us, nurtures us, and sustains every breath. It is held in place by gravity, but also protected by something invisible and powerful, our magnetic field. Deep within Earth, molten iron churns, generating a magnetic bubble that deflects the sun's deadly solar wind. Without it, our air would be stripped away. Without it, Earth would be a barren husk. Mars once had such protection too. Geological evidence suggests it had a magnetic field generated by a molten core. But then something went wrong. The core cooled, the dynamo died, and when the magnetic shield vanished, Mars was exposed. Imagine the scene. The sun, relentless and unshielded, hurls its solar wind directly at Mars. A storm of charged particles rips across the sky, striking the atmosphere, molecule by molecule. Hydrogen, oxygen, carbon dioxide, all torn away, swept into space like dust in a storm. Year after year, century after century, Mars was stripped bare. Today, its atmosphere is only about 1% the thickness of Earth's. It's mostly carbon dioxide, too thin to trap heat, too weak to support liquid water on the surface. Without pressure, rivers boiled away. Without warmth, oceans froze. The planet gasped, and then it fell silent. NASA's MAVEN mission has been orbiting Mars since 2014, studying exactly how this loss happened. Its instruments watch the sun tear at Mars in real time. During solar storms, plumes of atmosphere stream into space like ribbons. MAVEN confirmed what scientists had long suspected. The atmosphere was not lost in a single catastrophe, but in billions of tiny cuts. A slow death caused by the absence of a shield. But here's where the story takes an emotional turn. Think of Mars as a twin that fell ill. Earth and Mars were born from the same dust, raised under the same sun. One world flourished, wrapped in oceans, skies, and life. The other withered, left naked against the stars. And the difference came down to something invisible, something we almost never think about, a magnetic field, a shield we take for granted, but without which we too would not exist. Now pause and let that sink in. Mars is not just a planet, it is a mirror. It shows us how fragile worlds can be. It shows us how close we might be to losing everything if circumstances were only slightly different. Yet Mars also leaves behind puzzles. Even after losing its shield, why did its surface show lakes that lasted millions of years longer than expected? Did underground reservoirs hold on, releasing vapor to briefly thicken the skies? Did volcanic eruptions try to replenish the air, fighting a losing battle against the sun? Each crater and valley still carries traces of these struggles, locked in minerals and isotopes. And there is another haunting possibility. Maybe Mars never truly had the thick, warm atmosphere we imagine. Maybe it was always fragile, always on the edge of freezing. Perhaps its seas were shallow, its warmth fleeting, its habitability brief. If that is true, then life on Mars would have faced a ticking clock from the very beginning. But whether Mars was once lush or only temporarily kind, the outcome remains the same. Its skies thinned, its oceans vanished, and its rivers dried. The loss of its atmosphere is the reason Mars became the desert we see today. And yet, this isn't just a tale of loss, because even in its thin atmosphere, Mars holds secrets. Dust storms so vast they engulf the entire planet for months, clouds of water ice and even dry ice drifting through its skies. seasonal methane bursts that rise and fall mysteriously, hinting at unknown processes below. Mars' atmosphere, though faint, is alive with riddles. So as you look up at that pale Martian sky, remember this. It is both a grave and a clue. A grave because it buried the Mars that once was. A clue because within its chemistry and isotopes lies the story of how it died. And that story matters not only for Mars, but for us. Because if a planet so close, so similar, could lose everything, then it forces us to ask, what keeps Earth safe, and how long will it last? Next, we turn from the skies back to the ground, because even in this thin, fragile atmosphere, there are signs of activity, strange whispers of methane, minerals formed in fleeting warmth, and seasonal changes that tease at something alive. Could these gases be the last breath of Martian microbes hidden beneath the soil? Now imagine this. You're standing on the surface of Mars. The air is thin, the sky is tinted orange, and the silence is absolute. But somewhere around you, unseen, unfelt, a gas drifts quietly into the air. It is rare, it is fleeting, and it has set the entire scientific world buzzing. That gas is methane. At first, methane might not sound extraordinary. On Earth, we know it well, produced by volcanoes, by chemical reactions deep underground, and most importantly, by living things. In fact, the majority of methane in Earth's atmosphere comes from microbes and animals. It is, quite literally, a breath of life. So when methane was first detected on Mars, the world stopped and listened. Because if methane exists in the Martian air, then two possibilities exist, and both are thrilling. Either Mars is still geologically alive with volcanic or chemical processes bubbling beneath its surface, or something biological is producing it, something living. The discovery came in whispers. In 2003, telescopes on Earth reported faint signatures of methane above Mars. But telescopes can be tricky, their signals easily blurred by Earth's own atmosphere. Many were skeptical. Was it real or just an illusion? Then came the rovers. In 2014, NASA's Curiosity rover detected a sudden spike of methane in Gale Crater, 10 times higher than normal background levels. It was like a heartbeat, brief and unexpected. For a few weeks, methane filled the air, and then just as quickly, it vanished. Since then, Curiosity has continued to sniff the air, finding seasonal patterns. Methane rises in the summer and falls in the winter, like the planet itself is breathing. And yet, European orbiters circling Mars often see nothing at all, blank skies, no methane. The contradiction is maddening. How can methane appear and disappear so quickly? Where is it coming from? Where is it going? Here's what makes it haunting. On Earth, methane is fragile. Sunlight destroys it within a few centuries. That means if methane is present on Mars today, it must have been released recently. It cannot be billions of years old. Something, right now, in this moment, is releasing it. Picture that. Beneath the surface, in cracks and pores of the soil, there could be reservoirs of trapped methane slowly seeping upward. Or there could be chemical reactions between rocks and water, producing it afresh. Or, most tantalizingly, there could be microbes hidden underground, exhaling methane as part of their survival. The emotional weight of this cannot be overstated. We are not just searching for fossils of life long gone. We are searching for life alive today. Tiny, stubborn, invisible life, clinging to survival in a frozen desert. And yet, the mystery deepens. Why do orbiters sometimes fail to detect what rovers see? Could local pockets of methane be rising in bursts too small for orbiters to measure? Could the gas be destroyed quickly by unknown reactions vanishing before it spreads? Every answer breeds more questions. Think of the scene. A lonely rover rolling across Gale Crater lifts its tiny sensor to the air and catches a faint whiff of methane. It transmits the data across millions of kilometers back to Earth. Scientists gather, eyes wide, hearts racing. The numbers are clear. Methane is here. And then, weeks later, it is gone, like a ghost that only appears when you're not looking directly at it. Some scientists propose that Mars is breathing methane from underground reservoirs, in sync with the changing seasons. In the summer, as the planet warms, gas seeps upward. In winter, it is trapped beneath frozen soil. Others suggest chemical reactions in dust storms or ultraviolet radiation breaking down surface materials. But the possibility that captures imagination is always the same, the biological one. Because if methane is the byproduct of microbes underground, then Mars is not just a memory of life. It is a living world, even if only in the smallest, most fragile form. And imagine what that would mean. Across the solar system, Earth would no longer be unique. Life would not be a miracle of one planet, but a natural outcome of chemistry, arising wherever water and time exist. That changes not just science, but philosophy, faith, identity. It rewrites what it means to be human, living in a universe filled not with silence, but with neighbors. For now, the methane mystery remains unsolved. Curiosity continues its vigil. Orbiters continue their sweeps. Each detection, each non-detection, each spike and fall adds another piece to the puzzle. But the picture is far from complete, and this is where the story deepens further. Because methane is not the only clue Mars offers. The soil itself holds secrets, strange minerals, salts, and clays that whisper of chemistry that could support life. Organic molecules, carbon-based building blocks, have been found in rocks billions of years old. Each discovery adds weight to a haunting possibility. Mars may never have been completely lifeless. So let us move closer now, from the air above Mars to the ground beneath our feet. Because in the very soil and stone preserved in layers older than Earth's oldest fossils, the red planet may still hold the answers we seek. Bend down for a moment. Imagine kneeling on the dusty surface of Mars, your gloved hands brushing across the soil. To the naked eye, it looks ordinary, just dust, rocks, and sand. But hidden within these grains are whispers of something extraordinary, organic molecules. On Earth, organics are everywhere. They are the building blocks of life, carbon-based compounds that form the scaffolding of cells, proteins, and DNA. To find them is not the same as finding life, but it is finding the ink with which life's story can be written. For decades, scientists dreamed of detecting organics on Mars. The Viking landers of the 1970s carried experiments to search for them, but the results were confusing, muddled by chemical reactions in the soil. The disappointment lingered for years, leaving Mars painted as sterile, empty, chemically hostile. And then came curiosity. In 2018, its instruments revealed something that shifted the narrative. Drilling into 3 billion-year-old mudstones at Gale Crater, Curiosity detected a suite of organics, thiophenes, aromatics, alkanes, compounds rich in carbon, hydrogen, and sulfur. These were not fleeting gases, but solid ancient molecules preserved in rock. Pause and think about that. 3 billion years ago, when Earth's seas teemed with early microbes, Mars had lakes and mud rich in organics. Even if no life ever sparked there, the chemistry was tantalizingly close. But Curiosity didn't stop there. It also detected seasonal cycles of methane in the air, organics in the rocks, organics in the atmosphere. Two separate clues pointing toward a planet that once had the ingredients of life. Imagine the excitement back on Earth when these findings were announced. Scientists crowded into press conferences, voices shaking with wonder. It wasn't proof of Martian life, but it was proof that Mars had the chemical potential for it. For the first time in decades, the dream felt within reach again. Of course, caution remains. Organics can form without biology. They can be created by volcanic processes, by chemical reactions between rock and sunlight, even by meteorites delivering them from space. But the fact they are there at all, preserved for billions of years, is remarkable. Picture Gale Crater as it was, a vast lake, calm and shallow, with sediment drifting to the bottom. Over time, layers built up, trapping organics, minerals, and chemical signatures of its environment. Today, Curiosity drills into those layers, reading them like pages of a book, and the story it tells is one of possibility. Here's a thought to linger on. If Mars held organics 3 billion years ago and water flowed across its valleys and a thicker atmosphere kept it warm, what stopped life from taking hold? Or did it take hold, only to vanish when the planet lost its shield and dried? This is the knife's edge of discovery, because the rocks do not tell us why. They only whisper, the ingredients were here. And yet every ingredient matters. On Earth, life began not in a miracle, but in chemistry. Simple molecules combined, evolved, and slowly became complex. If Mars had the same chemistry, then maybe it walked the same path, at least for a while. Organic discoveries are not just about the past, either. They open the door to the present. If ancient rocks hold organics, might deeper layers hold more? Might something underground still be using them today? This is why the search continues, not just with rovers, but with future missions designed to bring samples back to Earth. Think about that moment. A rover drills into Martian stone, seals the sample, and places it into a tiny container. Years from now, a rocket will carry that container into space. Another spacecraft will catch it, bring it home, and deliver it to Earth. For the first time, human hands will touch pristine Mars rock filled with organics, waiting for answers locked inside. And when those rocks are placed under the most advanced microscopes on Earth, what will we see? Just carbon chains, lifeless and inert, or traces of fossilized biology, microscopic skeletons of Martian microbes. The difference between those two outcomes is the difference between a lonely universe and a shared one. Organic molecules are the bridge between chemistry and biology. On Mars, they are the bridge between memory and possibility. They tell us that life could have existed. They tease us with the idea that it might still exist. As you rise from that kneeling position in Gale Crater, dust falling from your gloves, you can't help but feel the weight of the discovery. Mars may not shout its secrets, but in its soil, in its rocks, it whispers them, patiently, waiting for us to listen closely enough. And so we must look deeper still, not just at chemistry, but at time. Because Mars is a world of cycles, wet and dry, warm and cold, hope and silence. To understand its true history, we must step back and see the grand timeline of its evolution. Only then can we understand not just what Mars was, but why it changed. Step back for a moment. Instead of focusing on a single crater or a single rock, let's stretch our vision across billions of years. Imagine Mars not as it is today, but as a living timeline, shifting, evolving, and fading. To understand the mystery of life on Mars, we must trace its entire story from birth to present. It begins 4.6 billion years ago in the chaos of the young solar system. Mars formed from the same swirling disk of dust and gas that gave us Earth, Venus, and the Sun itself. At first, it was violent, bombarded by asteroids, reshaped by collisions, its surface molten and unstable. Yet within that chaos, conditions slowly emerged that could nurture life. Around 4 billion years ago, Mars entered what we call the Noachian period. Picture it, a world with a thicker atmosphere, clouds drifting across the sky, rain falling into rivers that carved valleys across its surface. Oceans or seas may have covered parts of the northern hemisphere. Volcanoes erupted, releasing gases that thickened the air, trapping warmth. It was a time of possibility, a Mars that could have looked eerily like a younger, colder Earth. Then came the Hesperian period, roughly 3.7 to 3 billion years ago. The planet was changing, the magnetic field was gone, and the sun's solar wind began stripping the atmosphere away. Rivers still flowed, but they were less frequent. Instead, massive floods carved temporary channels, violent torrents rushing across the surface before drying again. Volcanic activity remained intense. Olympus Mons, the tallest volcano in the solar system, may have been erupting during this time, covering plains with fresh lava. But the climate was shifting toward cold and dry. Finally, Mars entered the Amazonian period, which continues to this day. Water largely disappeared from the surface, retreating into ice caps and underground reservoirs. The atmosphere thinned to the fragile veil we see now. Dust storms swept across deserts that had once been riverbeds. Mars became a world defined by silence and absence. Pause and let that timeline sink in. For hundreds of millions of years, Mars may have been warm and wet enough to support life. Then slowly, it withered. If microbes arose in its lakes or oceans, they had to adapt, retreat underground, or die out. The clock of habitability ticked down until the surface was no longer a home. This grand story is etched into the rocks. Every valley, every dried delta, every layer of mineral is a page in the book of time. The rounded pebbles curiosity found in ancient riverbeds tell us water once flowed for years, not days. The clay's perseverance studies in Jezero Crater tell us lakes endured long enough for sediments to build. The sulfates scattered across the planet tell us of waters that turned acidic as the atmosphere thinned. It is a tragic arc, a planet that began with hope, then slowly faded into silence. And yet, within that tragedy lies wonder. Because even if Mars is barren today, it proves that conditions for life are not rare. They existed here on our neighbor world, so close we can see it with the naked eye. And here's the haunting thought. What if life began on Mars before Earth? Some scientists suggest Mars cooled faster, became habitable earlier, and may have nurtured microbes long before Earth's oceans stabilized. If that is true, then life on Earth might not have begun here at all. Meteorites blasted from Mars by impacts may have carried microbes across space, seeding Earth in a cosmic exchange. In that sense, we might all be children of Mars. This is why the timeline matters, because it forces us to ask not just what happened there, but what happened here. It binds the fate of two planets together. Now imagine standing on the rim of Jezero Crater with perseverance. You look across the dry delta, the layers of rock frozen in silence, and you know this was once alive with water, maybe with more. If you could rewind the clock, you'd see rivers flowing, storms rolling across the horizon, sunlight shimmering on lakes. You'd see a Mars that was not red, but blue. And that contrast, the Mars of then and the Mars of now, is the essence of its mystery. Because it is not just about the loss of a world, it is about the fragility of habitability, the thin line between life and emptiness. From blue to red, from rivers to dust, Mars is a story written in time, a story that challenges us to look at our own planet differently. Because if habitability can vanish there, it could vanish anywhere. As we leave this sweeping timeline, our path turns toward the explorers of today, the rovers and orbiters that wander across this ancient stage, digging, drilling, and listening for whispers of life. Their mission is not just to read the past, but to uncover the truth that still lies hidden in stone and soil.